Welcome back. Today we're going to be talking about how to use multiple independent variables in your experimental research design. Now, before we begin, we saw a similar slide last time, but I just want to go over again a quick review of experiments. The experiments are attempting to establish causation through three ways. We've talked a lot about these. It's the covariance, handling that through manipulating variables. It's addressing confounds to make sure that there's internal validity, and it's establishing that temporal precedence by setting up the randomized groups so that the initial groups are similar, making sure that we're avoiding that systematic variability. In a good experiment, we are controlling for as many confounds as possible, and we have different designs that we can do to make sure that we're getting randomness and that we are putting our participants in different conditions and measuring the dependent variable in different ways so that we can address these confounds. And then last time we talked about the threats to validity. There were a lot of them, things that we need to be keeping in mind as we are doing a good experimental design. So that's where we're going to start off here when we're talking about multiple independent variables. Now, what we have been describing in our experimental designs so far have been what are known as one-way designs. Those are when you manipulate only one independent variable. All of the examples I showed, whether it's writing about traumatic experiences or measuring how much pasta people are eating, those have all involved one independent variable, and we're trying to see how that single independent variable influences the dependent variable. We're doing a lot to control for alternative explanations and design confounds and all of those so that the dependent variable's relationship to the one independent variable is clear, but this has just been with a single variable that we really care about. And we've seen it in both the between subjects design. This is when you have the random assignment into one of multiple groups. Each participant is in only one experimental condition, and these groups are independent of each other. They're called independent because the independent variable, they are independent because the person who is in one group, their scores do not affect the scores of the people who are in the other group. They are kept completely separate. Whereas the other alternative is the within subjects design, where you have a sample, they go through one level of your independent variable, and then they go through another level of your independent variable. In this case, each participant is in all experimental groups. And so any differences in the independent variable are going to be within the individual. The groups here are non-independent because the scores that are in one group are related to the scores that are in the other group because it's the same person. So that is, any changes you see are within the subjects and how they shift within themselves based on the level of the independent variable. Again, with between subjects, there's no relationship between scores from one individual and scores from another, or theoretically there's none. Looking at that between groups example, we've also seen it visualized in other ways. So I've shown you this bar chart here of the scores on writing versus thinking when you're evaluating well-being after the fact. And you can see here that the writing well-being was a 5 and the thinking well-being was a 2 in this specific experiment and this specific dependent variable measuring. So we can represent it with the bar chart, but I also want to show another way of representing it through a table. So here we have a table that has all of the same information. You have the means of 5 and 2. And what we're looking at here is one thing is the factor. One kind of cumulative on the y-axis here is the factor. Now, factor is a new term. That is just another way of saying independent variable. And this is going to come into play later when we start talking about factorial things. That just means has independent variables. So the independent variable here, or the factor, is the mode of processing. We then have our different levels of the writing about the traumatic event or the thinking about the traumatic event. And then in our cells, we have the specific group means related to the dependent variable. How well did people in that level of the independent variable score on the dependent variable? And what we are doing is comparing the means in one cell against the means of the other cells. So the mean 5 compared to 2, and we want to see if those are different. And to do this, we are going to run an independent samples t-test. So in this table, you see that if there are 2 levels of the independent variable and they are independent because this is a between subjects design, then the analysis we use is an independent samples t-test. We can do the same thing with the within subjects design here, where you have the sample that goes into both levels of the independent variable, both thinking about the traumatic event and writing about the traumatic event. And here I changed up the data slightly so you can see in the bar chart to the left that those who were in the writing first condition, they scored a 4 on the dependent variable for well-being, and in the thinking second, they did a 3. So you see how that matches up to the different levels of the independent variable. And once again, on the right, we have this table where you have the factor of mode of processing there along the y-axis. And then you have the row for writing first and the row for thinking second, which are the two levels of the independent variable. And then you have within the cells the mean scores for each of those dependent variables. And if we are running this analysis, we have two levels of the independent variable, but this time it's a within subjects, so we don't have independence. Instead, we have non-independence here because the same people are taking both levels of the independent variable, so they are related to each other, they are not independent from each other. And in this case, you would run a paired samples t-test, which you might remember from your statistics course. Now, going into too much of the explanation of why we use a paired versus an independent samples is a little bit beyond the remit of this course. That is more of a statistics that you need to know. But you can remember that if there is non-independence, if it is a within subjects design, that is what we're talking about when we're choosing to run the paired samples t-test. That being said, it is important when you're designing an experimental design to understand when your participants might not be independent from each other. And there's a number of different things to look for. The first is to identify any natural pairs you have. Those are going to be non-independent. What this means is that you can kind of theoretically pair them due to natural factors rather than anything the researcher specifically is manipulating. A good example of this is the parent-child relationship. If you have your sample has both parents and children in it, while these are independent individuals on like a big picture, it's you have a parent and then you have a child, they are inherently related to each other and have a lot of overlap in personality and genetics that may result in the way one of those pairs responds might be very similar to how the others. And conceivably, the child will take on a lot of the same behaviors and parents learn from their children too. So treating them as completely unique and not related to each other is inappropriate. So we want to represent them as non-independent. We want to match them together. And so if you are doing a study, usually you would have in one condition the parent and one condition the child. And you wouldn't just say, okay, how do all parents respond one way and how do all children respond another way? You would instead want to see how does this parent respond compared to their respective child. You want to pair them up and do that paired samples analysis. Another way is through matched pairs, where the subjects are paired prior to the study, and you have one member of the pair getting one kind of treatment and the other member of the pair getting the second. This might be that you've matched people on a lot of variables or the important and salient variables in your study, such as you're trying to get people who score similarly on an exam like the SAT, ACT, with the assumption that, okay, if they are similar on this variable, then any other differences that they manifest are going to be external to that variable and are the reason there's something on the dependent variable. We also do this with twin studies where, yes, they have a lot of overlap in genetics, which might be similar to this natural pairs, but we are going to assume that we are controlling for those genetics. And so we are going to put one participant, one twin in one condition and one twin in the other, and we think of them as matched on those variables. Whereas a parent and child aren't necessarily matched because we know that they are distinct in a lot of ways based on age and life experience. And so that's going to be more of a natural pair. The other way is through repeated measure. This is where you have the same individual. They're not matched with anybody else. They don't have any pairing. It's just them, and then they are getting multiple treatments. So this might be in a pre-test, post-test design where you're measuring them at one time point and then measuring them again later. That person's score at time 1 is non-independent from their scores at time 2 because it is the same individual. So we can't treat those measurements uniquely because there's going to be, of course, so much overlap in variability by being from the same source. So in inferential statistics, if the groups are independent from each other, you're going to use that independent samples t-test. Again, here's kind of how it looks with those bar charts, and we could also do the table. And if the groups are related to each other, that is, they are non-independent, and we had those 3 ways that they're non-independent, you run that paired samples t-test. Now, what happens though if you have more than 2 groups? So if they are independent, if the group means are independent from each other, there's no pairing, no matching, no repeated measures for more than 2 groups, that's when you're going to run a one-way ANOVA. So here we have an example data of the average cafeteria food rating for 9th, 10th, 11th, and 12th grade high school students. And you have on the x-axis, you have the different groups. So whether you're a freshman, sophomore, senior, junior, or senior, and then how your food rating. So we can see here that it looks like the freshmen seem to appreciate the food a little bit more than those seniors. And we would run an analysis to see which of those groups are different. Is it that only the green 9th graders have a different score from the 12th graders, or do the juniors also have a different score from the seniors, those yellow scores? What about the 7.75 for the 10th graders? Is that one different from the pink 12th graders? We need to run those analyses. And so what an ANOVA is doing is running all of the different pairs. So comparing 9th to 10th and 10th to 11th and 11th to 12th, and then 9th to 11th and 9th to 12th and 10th to 11th. Basically, every combination of pairs you can do is running them simultaneously, and it's accounting for the amount of error that comes from running multiple pairwise comparisons. It averages all of that noise and that variance together, and it comes out with, yes, these groups are different, and then you do some kind of post hoc analysis to determine which pairings are actually different. Because that 8.35 for the 9th graders versus the 11th grade 8.04, that one, I don't know, maybe that's significant, maybe it's not. We would have to run this ANOVA to find out. So again, a t-test is only looking at 2 levels of an independent variable. Now you can have multiple levels of an independent variable that exist, that are available, but if you're only comparing 2 of them, that's when you do an independent samples t-test. Some of you have seen this when you are running analyses using year in school in our survey, and you have seen that, oh, I can't run an independent samples t-test looking at freshmen, sophomores, juniors, and seniors. Instead, you have to select just 2 of those groups for your independent samples t-test. Okay, so that's all about when they are independent from each other. You don't have a relationship between the different levels of the IV or the participants in each level of the IV. But if the group means are related to each other and you have more than 2 groups, then you run what's called a repeated measures ANOVA. You see how that's similar to the one-way ANOVA? One way is when you only have 1 level of independent variable, but the repeated measures is suddenly you have some non-independence, and you have specifically one version of non-independence, so you call it the repeated measures. Now, I want to be clear that though it's called a repeated measures, and that matches the repeated measures non-independence that we saw earlier, that is kind of a misnomer. You can use a repeated measures if you are doing any kind of non-independent sample, whether it's a matched pair or a natural pair. Repeated measures will still work. It is just the version of ANOVA that you use when there is non-independence and more than 2 levels of your independent variable. As another way of understanding the repeated measures ANOVA, one version of this multi-level non-independence is when all of your participants are responding to the DV at multiple time points. So here in this visualization, you have the same people in time point 1 who are responding to your dependent variable. In this case, it is blood pressure. Maybe this is before you've done any kind of intervention, any kind of analysis. And then they do your intervention, and then they come to time point 2, and we remeasure their blood pressure at the same participants at a different time point. And then time 3 happens, and this is our 3rd level of a variable, which takes it outside of the paired samples. Now we have different comparisons we're doing with beyond just the 2 levels. So we take the time point 3 dependent variable, and we are going to then run a repeated measures ANOVA. The idea here is, again, we can't just compare two levels. We can't just say, is time point 1 related to time point 2, and then is time point 1 related to time point 3, and is time point 2 different from time point 3. Those different pairwise comparisons, if we ran all of those pairwise comparisons, it would create a lot of noise in our analysis, and that wouldn't be an accurate analysis. And so we have to instead run all of those pairwise comparisons at the same time and then look for whether or not any of the groups are different, any of the time points have different scores, and then we can do our post hoc analysis to find which time points are different from each other. Another version of a repeated measures ANOVA is when you change up what kind of treatment or intervention is being done at any one time, again, to the same participants. So maybe you are starting with one kind of intervention, which is, all right, we want to measure your taste. We're going to try chocolate score or chocolate cake first. And so that's the one treatment condition, is eating chocolate cake, and we're assessing their how much they enjoy the chocolate cake. And then we take the same participants later and we measure their taste of caramel cake. How much do they like that? And then we take the same participants later and we measure them eating lemon cake and how much do they appreciate the lemon cake. And we are having the same participants, same subjects in all of those three conditions at different times. So they are still in all three levels of your independent variable. It is repeated that we are measuring the same individuals, and then any differences that we see from that individual are going to be due to the treatment, due to what kind of cake they are eating, rather than anything else. And it's this non-independence because it's the same individual, so they're going to come in with the same taste buds, they're going to come in with the same historical preferences. So again, any changes we see between these groups is subsumed into the within person variance in how much do they like different cakes differently, versus differences between individuals where you'd have, which if we were going to do this as a between subjects design, we would have some participants in the chocolate cake version, some participants in the caramel cake version, and some participants in the lemon cake that are all unique. So a repeated measures ANOVA uses the same participants in all levels of the independent variable. So choosing what kind of test you are going to run depending on the independence and number of variables is very important, especially if you're trying to figure out whether it's a between groups or within groups analysis. Because if you don't do the appropriate within groups analysis, whether that's the paired samples t-test or the repeated measures, then a lot of that variance that comes from the overlap between individuals is lost. So let's look at which test do we run depending on certain situations. This again should be a lot of review from your statistics course, but hey, we're doing it again. So what we are looking at here is the rows reference whether you have one independent variable or more than one independent variable. And then the columns are whether or not your independent variables have just two levels or more than two levels. So let's start with what we already know. Let's say we have only one independent variable, so it is a one-way analysis, and all of our independent variables have only two levels. In this case, you would run a two samples t-test, and those can be either an independent samples t-test when there is independence, or it can be the paired samples t-test when there is non-independence between them. So independent samples is a between subjects, whereas a paired samples is a within subjects analysis. A question you might run for this is, does drug X work better than drug Y? Here you have one independent variable, which is the drug type, and you're measuring whatever better is, whether it's health or side effects, that's your dependent variable. But the important part here is there is one independent variable, which is type of drug, and it only has two levels, which are drug X or drug Y. And whether or not their participants are in both drugs, they've taken both at different times, or whether they are taking just one drug or the other, is going to determine whether you're using that independent samples or the paired samples. So let's say we also have a different study where we only have one independent variable, but we have more than two levels. Maybe we're introducing another level outside of drug X and Y. Maybe it's drug Z or it's no drug. Then when we have multiple levels or beyond two levels, we're going to do those one-way ANOVAs or the repeated measures ANOVA. These are known as one-factor ANOVAs. So one factor is different from the one way or one measures or the repeated measures. It's just saying that there is only one IV there. Again, we might see it as there's drug X, drug Y, and no drug. We now have 3 levels of the independent variable, but there is only one independent variable, that drug therapy. All right, so these are the ones that we've been talking about so far in our labs. Where I just kind of went over the paired samples and repeated measures ANOVA and making sure you understood the independence versus non-independence issue. So now we're going to go into the real heart of what we're talking about today, which is what happens, what analysis do you do when you have more than one independent variable? So first, if you are going to run a study where you have multiple independent variables, maybe you don't just care about drug therapy, maybe you're also looking at how the participant's gender, whether they're male or female, how does that have an influence as well as drug therapy on depression or well-being. So in this case, when you have more than one independent variable, such as drug therapy and gender, you need to ask yourself, well, are there only 2 levels of each? And if there's more than one independent variable and you have just 2 levels, you're going to run a factorial ANOVA. Now, you're actually going to run a factorial ANOVA if there's more than 2 levels as well. So that's a little bit of a, well, which kind do you run? It's just going to be a factorial ANOVA. If you ever have more than one independent variable, it's factorial. And I said earlier that the word factor means independent variable. So a factorial means lots of independent variables that it's analyzing. Another example of a factorial ANOVA might be you're trying to find what are the effects of parental divorce and gender on depression. You might have multiple levels of gender, or maybe you're just treating it as 2 levels, or you have multiple levels of parent divorce. Maybe they're together, maybe they're single and remarried, single and stay single. Those could be more than 2 levels there. And so anytime that you have any independent variable that has more than 2 levels, you can run a factorial. And anytime you have any multiple independent variables that have just 2 levels, again, you can run a factorial ANOVA. So let's look at a classic example of American Idol. So let's say I'm a researcher and I really enjoy American Idol. Let's pretend that that's a thing. And I'm trying to understand the average votes that an American Idol contestant would get, or any kind of game show where you get to see the individual. And I want to know, okay, I know it's all about singing, but I wonder if the attractiveness of the participants and their gender seem to matter. And I could be a very simple researcher and just say, okay, I'm going to run one study that looks at attractiveness related to the votes that the contestant gets. And then I could go later and run a second study looking at how gender relates to the mean votes. But I'm going to be a sophisticated researcher and I'm going to run them at the same time. And this is going to give me some advantages that we'll talk about a little bit later by running them simultaneously. But I'm going to look at them in one single study as a factorial ANOVA, because in this case I have 2 independent variables. And when I write out, model out my analysis, I'm going to put together a table, and in this I'm going to have a row. All of my rows are going to represent the first independent variable, which I'm just going to do as gender, and this is going to have 2 levels, the male and female. And then I'm going to have a column which is going to be the independent variables and the second independent variable, and in this I'm going to use attractiveness. And here this one can have multiple levels besides just the 2, and I'm going to do 3 levels here: a very attractive, just okay, and the unattractive condition. And this is how I'm going to dichotomize the attractiveness, or categorize the attractiveness. So I could design it in my table, write it up here. I have my rows of male, female. I'm going to write this as my A variable, and then I have attractiveness as my B variable. So I can see each of the combinations of the attractiveness and gender. So you have the male and the attractive is going to be your A1, B1. And then you have your male and they're just okay, which is your A1, B2, and on and on. And you can see in parentheses, I have M for average. And what's going to happen is as I run this study, I am going to be collecting the average vote for the American Idol contestant based on what combination of conditions they fall into. So the average scores for attractive males is going to go in that first topmost left cell. And then the average scores for the unattractive female is going to go in that bottom right cell. And I'm going to do it for all 6 combinations of the levels of my independent variables. And once I put that together, I can do analysis. And because this has 2 levels of the first IV and 3 levels of the second IV, this is described as a 2×3 factorial ANOVA. The numbers there just represent the levels of each independent variable. And as you have more independent variables, which you can do, doesn't need just 2 independent variables, you add more and more numbers with that x times symbol, and you just put how many levels you have of each independent variable. So anytime you see a factorial ANOVA described, you can just look at those numbers right before to tell how many independent variables there are, which you can see there's 2 numbers, so there's 2 independent variables, and you can see how many levels of each. I do want to make sure you know that these are interchangeable though. I chose that gender was the first IV and attractiveness was the second simply for my demonstration, but it doesn't actually matter at the end of the day. You could call this a 3×2 factorial ANOVA if you wanted, and you just flip the table, you flip how it looks, and that's fine. It's still 2 independent variables. One of them has 3 levels of the independent variable and one of them has 2, or vice versa. Not a problem. So let's once again see how these factors are laid out in this table. So here I again have 2 factors, factors A and B. This time I switched it. The A is along the x-axis and the B is along the y-axis of our table. So we have factor A has 3 levels, A1, A2, A3, and factor B has 2 levels, B1 and B2. Each cell is the combination of the A's and B's based on its numeral 1, 2, 3 or 1, 2 respectively. And then in parentheses, again, you have that mean for the cell. So that is each group, each category of interaction between the 2 different factors has its own mean. So the participants who are A1, B1 have mean 1, and the participants who are A1, B2 have mean 4. I also want to point out that there are marginal means here. The marginal means are what come at the end of the row. So for the end of the row B1, for that level of factor B, you have the mean of B1. So what that's doing is it's combining all of the scores for anybody who was in the B1 condition, and it's giving them a value regardless of which level of the factor A they were in. So for that mean of B1, you're ignoring the presence of factor A. You're pretending like it doesn't exist. The same thing with mean for B2, that's every participant who was in the B2 level of factor B has an average, ignoring which condition they were in for factor A. We then have the same thing with the marginal means for the columns. So along the bottom row, we have the mean for everybody who is in the A1 for factor A, and we are ignoring factor B, and we do the same thing for the mean for A2 and A3. And then finally, we have what's called the grand mean, which is taking everybody's score on the dependent variable, their average score, and we don't care which group they were in, which IV they were in, which cell they were in. None of that matters. We're just getting the average score for all participants at the same time. So I want to be clear that there's these marginal means which are just looking at one factor's mean, the average scores within a level of one factor, and then the grand mean, which is looking at everybody's scores all by themselves. So we have our cell means, we have our marginal means, either for the row or column, and we have our grand mean. Those of you who are astute will notice that these marginal means look exactly the same as what I had earlier in this slide, where I had that mode of processing with writing and thinking and just that very small table there. If you take out all of the factor A and you're just looking at factor B, in this case mode of processing and the levels of writing and thinking, it matches completely onto those marginal means. In fact, when you are doing a paired sample t-test or an independent sample t-test, or really actually any kind of one-way analysis, that is just this table minus the other factor. It is only when you start to include that other factor that it gets more complicated. So the marginal means are as if there was no other factor present. Let's return to our running example about thinking about or writing about an experience in order to process it. And we're going to still continue with the independent variable of mode of processing, which is whether you're thinking or writing, but we're going to add in another factor or another independent variable. And this time, instead of just focusing on negative traumatic experiences, we're going to focus on the valence of the experience, which just means was it a positive experience or a negative experience. Maybe as researchers, we're interested in whether there's a difference between thinking about a negative experience versus a positive experience, writing about a positive or a negative experience, whether if it's a positive experience, we're thinking or writing about it, this combination of independent variables and how those might affect well-being in the long run. So we have two independent variables, each with two levels. So you could think to yourself, this is a 2 by 2 factorial ANOVA that we're going to be doing. We can diagram out our 2 by 2 factorial ANOVA here by having our two factors, mode of processing and the experience's valence, on our X and Y in our table, and then we have each of the levels, whether it's the writing or thinking for our mode of processing independent variable, or it's the negative or positive valence for our experience valence independent variable for that factor. And then within each combination of those independent variable levels, we have a different cell mean. With two of each level of each independent variable, that means we're going to have 4 cell means. So in order to analyze any data that we collect from this factorial ANOVA, we're first going to start with what's known as a main effect. This is an overall effect of a single independent variable on the dependent variable. I want to be clear here that this is when we are ignoring the other independent variable, and we're going to then have to do 2 different independent variables. So one for our first independent variable and one for our second. The main effect is looking at a single variable without or ignoring the other independent variable. This is traditionally what we've been talking about so far. This is basically a one-way analysis because we're only looking at one independent variable at a time. And for this, we are going to compare the marginal means that I talked about earlier. Those means when we are averaging all of the scores within one level of an independent variable, ignoring the other independent variable. Looking back at our table, we can see which cells we're combining in order to get this marginal mean. So in our valence independent variable, if that's what we're trying to look at right now as our main effect of negative versus positive experience, how does that affect well-being? We would combine both of the 2 cells for the negative experience, the negative valence, and we would combine those to get the marginal mean of the negative valence. Again, we are combining the writing and thinking. We're pretending like the writing and thinking mode of processing independent variable didn't happen. There weren't 2 other groups, 2 other cells or anything like that. It's just everyone who is doing anything related to a negative experience. And then we do the same thing for anybody in our study who is doing anything related to a positive experience. We're going to combine those cells and average them to get the marginal mean of the positive valence. Those 2 marginal means at the bottom between negative and positive, we're going to compare those, and if they are different, then that's going to be a main effect. And if they aren't different, then we find a non-significant main effect. This is exactly the same as you've done with your independent samples t-tests. The difference, though, is that we have 2 factors this time, so we also need to get a main effect for the mode of processing. And we do exactly the same thing. We're going to combine and average the 2 cells that are associated with the writing mode of processing. Regardless of what they're writing about, whether it's a negative or positive, we don't care. Just if they were writing in our experiment, We're going to combine all of those data and we're going to get a marginal mean for writing. And then the same thing for thinking. We don't care whether they were thinking about a negative or a positive experience, just if they were thinking about an experience, we're going to average those participants together and get the marginal mean of thinking. We then compare the marginal mean of writing versus the marginal mean of thinking, and if those two averaged scores, the well-being for those who wrote and those versus those who thought, if those are different, then we have a significant main effect of mode of processing. Now within a factorial ANOVA, you have one effect for each independent variable that you have. So if you're running a 2 by 2 factorial ANOVA, that is two variables, each of them have two levels, then we are going to get two main effects. It doesn't matter how many levels there are for each independent variable. You could have a 5 by 6 factorial ANOVA and you would still only do two main effects because you have two independent variables. Now, if you have more independent variables, you have three maybe independent variables in your study, then you would get three main effects. If you have five independent variables, then you'd have five main effects. A main effect is done for each independent variable and you're ignoring the other independent variables. But we want to go one step further than just doing these main effects. The main effects we could do through our one-way ANOVAs and through our independent samples t-test. Instead, we want to add another little benefit through our factorial ANOVA, and that's going to be doing simple effects and interactions. So going back to our main question, we're trying to figure out the effect of writing versus thinking on negative or positive experiences. But we might have a sub-question below that. So specifically, we might want to know that for positive experiences only, is there a difference between thinking and writing about that experience? Do people have greater well-being after thinking, or is it better to write about that positive experience? So here we're only looking at the independent variable related to the dependent variable at one level of the other. So we're looking about how the mode of processing affects our dependent variable, but only looking at the positive valence level of the second independent variable. We might also have a sub-question that's the other way around of what about the same thing for a negative valence, where we want to know, does the mode of processing matter when we're thinking about only negative valence? You see here how we are looking at the effect of the independent variable mode of processing on the dependent variable, but we're switching the level of the second independent variable. We are looking at the effect of one IV on the DV at only a single level of the other IV. This is what's called a simple effect. We are comparing the cells that lie in the same row or column. That's the way we're doing it, but it's saying within one level of an IV, is the other IV still having an effect on the DV? So again, we do this through a comparison between the cells that lie in the same row or column. So going back to our table, we see here that I am trying to look at a comparison between the numbers, which are the means in each cell. And for the first one on the left, we are looking at a comparison between the dependent variable scores, those hashtag numbers, for those who are writing in the negative experience versus those who are thinking in the negative experience. This is a simple effect of the processing independent variable when only looking at the negative experiences, so the level one of the other IV. But we also have a simple effect of the writing versus thinking when only looking at the positive experiences, the simple effect of processing when examining positive experiences only. So here we have two simple effects, because there are two levels of the experience, the valence independent variable. So we have two ways we can do it. But there aren't just two simple effects in a 2 by 2 factorial ANOVA, because you can also switch it up and look at the other combination of independent variables and levels. So here's the other way you can look at those simple effects. And this is the same kind of thing. Here we're just trying to find out, does the experience matter when we're writing about something? Now, if you are writing about an experience, do you get more well-being if you're writing about a negative experience or if you're writing about a positive experience? And then we could ask a second sub-question of when you're thinking about an experience, do you have better well-being when you're thinking about a negative experience or when you're thinking about a positive experience? And we're doing that comparison. So we have the simple effects of the valence when examining people who wrote about it. And then you have a simple effect of valence when you're examining just people who thought about it. So within a single level of one IV, you're looking at the effect of the other IV on the dependent variable. So we now have two different things that we're looking for in a factorial ANOVA. The main effects, which is just the single independent variable related to the dependent variable, and then the simple effects, which are the effect of one IV on the dV when looking at only one level of the other independent variable, looking at those cell comparisons within a single row and or column. But the last thing that we can do is what's known as an interaction effect. Returning once again to our overall question, you might have a third kind of sub-question here, and that is whether there is an effect of thinking versus writing on experience well-being, but is that different based on whether it's a positive or a negative experience? So this is looking at the combination of the two independent variables. How is one independent variable affecting the dV when looking at the combination of different levels of the other independent variables. So we're trying to see this positive on the mode of processing versus negative on mode of processing. Is thinking about a negative experience better than thinking about a positive experience? And is writing about a negative better than writing about a positive? This combination thing, it's called an interaction because we are combining all of these different levels of independent variables and the effects of the different independent variables simultaneous. And the way we're going to do this is by comparing those simple effects that we already talked about. So this is called an interaction, and it is testing whether the effect of one independent variable depends on which level of the other IV you are looking at. And this is just testing those differences between the simple effects. Because remember, a simple effect is looking at the effect of the IV on the dV when looking at only one level. The interaction is looking at, well, okay, we have one level's simple effect. Let's see if it's different from the other level's simple effect. It is a difference of differences. So going to our example, we want to know, is this difference here, this simple effect for writing, when you are writing, what is your well-being when it's writing about a negative versus a positive compared to this difference? When thinking about an experience, is it different whether it's negative or positive? Is there a difference between these two simple effects? And just like simple effects, we showed there was multiple ways of looking at it. The same is true for an interaction. We could look at the simple effect difference within the negative experience, whether you're writing or thinking about it, compared to the simple effect of within a positive experience, what is the dependent variable, what is well-being when thinking versus writing about it. You are comparing the differences of the differences, because if you find that it is people are better off, they have higher well-being when they are writing about a negative experience than a thinking, so there is a difference there between writing and thinking within a negative experience. Well, is that the same as when you are writing versus thinking about a positive? So maybe we find that thinking about a positive experience is really good, but writing about the positive experience isn't great. So in this example, I'm kind of coming up with off the top of my head, writing about a negative experience maybe is really good, but thinking about a positive experience is also really good, and the other inverse isn't necessarily true. We want to know, does the combination of levels of independent variable have some kind of effect? That is what an interaction is doing. Because there's so many ways of looking at this interaction effect, because you can have different combinations of simple effects to get this interaction, there can also be many ways that the interaction effect manifests. The first is a crossover interaction. This is when the effect of one independent variable on the dependent variable at a level of the second independent variable is opposite of the same effect of that one independent variable on the dependent variable when looking at the other level of the independent variable. So it reverses depending on which simple effect you are looking at. So again, in our example, we had two simple effects, and if they swapped directions, if they were very different from each other in opposite ways, we'd get a crossover interaction. So let's do that with a little bit of numbers. So here we have different visualizations of a crossover effect, and you can immediately see it's called a crossover because you have that X on the line graph there. But on the left table, I'm going to give you some numbers here, and these are, let's say, well-being scores. So in this example, we have that when a participant is writing about a negative experience, their well-being is a 4.3, so relatively high here. But when they are thinking about a negative experience, it is lower at a 2.5. So the simple effect of looking at writing versus thinking when only talking about negative experiences, we see that, yes, there's an effect. Writing is better than thinking. But then we have another simple effect, which is that positive column. And we look at the writing score for a positive experience is a 2.4, and thinking about a positive experience is a 4.4. So here we have another simple effect where there is an effect of writing versus thinking when talking about a positive experience, but that effect is opposite from when we were doing a negative. You see how it switches, it reverses the effect of motive processing on our well-being depending on which level of valence you're at, whether it's negative or positive. And we visualize this in a bar chart. You can see the 4.3 and versus the 2.4 within writing, whether it's a negative or positive experience. And you can see the 2.5 versus 4.4 when you're within the thinking, when you're comparing a negative versus a positive experience. And then you can put this in a line graph and see that when you are crossing from the 4.3 within a negative experience, the negative is the solid blue bar. So when you're in a writing about a negative, you have a high well-being, but as you shift to thinking about that negative experience or a negative experience, we go down in our simple effect. There's a switch there, but if we are writing about a positive experience, the light blue dotted line, then we start off with writing about it, not too good for well-being, but when we just start thinking and ruminating on the positive experience, then we go up to a 4.4. So it is switching and reversing the simple effects. That is a crossover interaction. And of course, we could look at it a different way. Here we have the exact same data, but for the visualizations, I have switched up the x-axis to be the valence, and then the color, whether it's a solid blue or a dotted light blue, that is now the independent variable of mode of processing. So you can see, again, same data here within the negative experience. We have the mode of processing 4.3 versus 2.5. And then within the positive experience, the mode of processing writing is a 2.4 and the thinking is a 4.4. Exact same data, we're just looking at it different. And then in our line chart, we see that the shift from the 4.3 for a negative writing experience, well, if we keep doing a writing experience and we're writing about a negative, that's fine. That's good to write about a negative, get the thoughts out. But then when we switch to a positive writing about it, it's not really doing too much. Maybe it just gets out of our head in not a great way. Whereas if we have the negative thinking about an experience, the 2.5, well, just kind of ruminating on that negative, not so good. But when we start to think about a positive, well, that rumination on a positive experience at 4.4 is better. We're having a switch. This time we've just switched which independent variables we are using as independent variable 1 on the dependent variable versus the levels of independent variable 2. This is exactly the same thing we did when we were looking at the different ways of looking at a simple effect. Interactions are just simple effects. That's it. I want to look at one more example of a crossover effect, a crossover interaction effect. Now, this is the same thing, but before we saw that there was like an X. It's very clear in the line chart that there was an X where they're crossing over. But here's some new data. It's the same premise, but you'll see over in the line chart, after you review some of the data here, that the line chart is still different effects, different simple effects. We're seeing different slopes depending on which level of independent variable we're looking at, but they don't actually cross over each other, but it's still a crossover interaction because those slopes are different there. That as you are within the when you're looking at negative versus positive experience within the level of writing or thinking, you're changing your slope there. So still a crossover because the direction of the effect is reversing depending on the other level of the other IV. Another version of an interaction is what's known as a spreading effect. This is where the effect of one independent variable on the dependent variable is stronger at one level of the other IV than it is at the other level of the second independent variable. So it's just saying that there is always an effect of the first IV on the DV. It's built up more, it's stronger, it happens more often when you are looking at one level of the second IV versus the other. So this is just when the simple effects are in the same direction, or maybe there's only one simple effect, but you're seeing that the strength of the simple effect increases depending on which simple effect you're looking at. So here's some data where we can see this. Here I have the leftmost table here with the 4.8 versus 4.2 within a negative experience based on the mode of processing. And then we have the 4.6 versus a 2.2 on the positive experience within the mode of processing. Or we could look at it in our visualization of within writing, whether you're writing about a negative experience versus a positive is the 4.8 versus a 4.6. Or within thinking, you have, when you're just thinking about an experience, if it's a negative experience, you have a well-being of 4.2 versus a 2.2. Again, these are made up data, and before they were made up data as well. So don't take this and go to your friends and say, oh, I just learned that thinking or writing is better or worse depending on this. These are just data for showing off the interaction. In the visualization, though, what you can see here is the change in the slope where both slopes of those effects are in the same direction. They're both showing a negative slope, that when you are looking at just the negative experiences, where you have that solid blue line, there is a negative slope from writing to thinking. It goes from a 4.8 to a 4.2. So then you compare it against the other simple effect of the positive within the level of positive for the valence, that is the light blue dotted line, and you go again a negative slope from writing to thinking of a 4.6 to a 2.2. Both are in the same direction, but one is stronger. It is a steeper slope in that line graph, and that's how we're seeing the simple effect. This is spreading because you can see how it starts off together and then it spreads wider and wider apart. A crossover is when they are in opposite directions. A spreader is when they are in the same direction and build kind of bigger as they go, more farther apart, more accentuated, depending on which level of the IV you're looking at. Here's another example. This is changing the data again. Don't go home to your friends because it's just made up data. But here we see that within the writing level of the mode of processing independent variable, when you're looking at negative versus positive, you have a 4.5 versus a 2.5. And then within the thinking level of the mode of processing independent variable, you have the negative versus positive as a 2.2 to 2.2. So you can very clearly see from the bar chart that the 2.2s within thinking are exactly the same. There is no effect there, but then within the writing condition of the mode of processing, there is very clearly an effect. So whether you're writing, when you are writing, whether it's a negative or positive really seems to matter, but when you're just thinking about some kind of experience you've had, whether it's negative or positive, it doesn't really matter at all. And when we look at this in the line graph, we can see that you start off with a 4.5 in the negative experience and then go when you're writing about it, and then it steeply slopes down to a 2.2 in the thinking about a negative experience. Whereas in the positive experience, that dotted line, you start off at a 2.5 for writing and go over to a 2.2 for thinking. This is a spreading interaction. Now, spreading here, you're seeing a narrowing, but you could always just flip it and do the thinking first and then the writing, and it's no matter what, you have different effects, but they're both in the same general direction, or one of them is kind of a null effect here. So this is spreading versus a crossover interaction. So this interaction and factorial ANOVA analyses are definitely a complicated phenomenon. And so let's just go over a slightly different wording of these different effects. The main effect is when you have an effect of an independent variable on the dependent variable when you're ignoring all other factors. So in an example of a 2x2 factorial design where you have gender and age as your two factors. You have male versus female in one factor. Those are the levels. And then you have a young child versus an adolescent as your two levels of your second age factor. Well, then you can look at this main effect of what is the effect of gender on, let's say, depression as our dependent variable, absolutely ignoring age, the other independent variable. Or you could look at it the other way. Well, you will look at it the other way because you have two main effects in a two-factor factorial ANOVA. You have the effect of age on depression, and you're absolutely ignoring any effect of gender. This main effect is what you are used to seeing in a one-way analysis. Another way of wording the interaction, this is just saying that the situation in which an effect of one IV on the dV depends on the level of the other independent variable or the other factor. So in this sense, it would be the effect of gender depends on what age the child is. Maybe girls are more depressed than boys when they're adolescents, but then you might find that boys are more depressed than girls when they're young children. The effect switches depending on the levels of each independent variable. The effect of one independent variable in the dV changes depending on the levels of the other independent variable. That's what we get. That's the advantage that we get from doing a factorial ANOVA by being able to combine and look beyond just the main effects. So hopefully you've been able to stick with it so far with a lot of this conceptual terminology and following which cells are averaged together and what the simple effects are comparing and the main effects. But it's still, again, at a top conceptual level at the end of the day. It's sometimes, if you've gotten this far, easier to actually look at some numbers and see how that works. So I'm going to have a number of examples now for the rest of the lecture, and these are going to be made up data, but we're going to work through them with actual numbers and showing what cells are going to be averaged together and how it's interpreted as main effects versus simple effects and interactions. So let's go over example data pattern number 1. Here it is. This is pretty basic. Everything is a 4 well-being. So when you're writing about a negative experience, you're getting a 4. You're thinking about a negative experience, you're getting the average score is a 4. The average, no matter what situation you're in, the average well-being is a 4. So let's check all of the different effects. The first, this is a visualization of how this looks in a graph. Okay, 4 across the board. Whether you're thinking, writing, okay, we're good so far. So we first want to ask ourselves, is there a main effect of valence, right? Remember, we have two main effects. One is for the valence and one is for the mode of processing. So the first, main effect of valence. Here we're going to look at the valence for negative versus the valence for positive, and we are going to ignore the mode of processing. So here we average the 4s for the negative and we average the 4s for the positive. Each of those will create a 4, and then we see, are those 4s different? And we'd run our statistical analysis to say, is 4 different from 4? And you can guess that no, there's no difference there. So we would say these marginal means are not different. So no, there is no main effect of valence. We then ask ourselves the second main effect, is there a main effect of mode of processing? So we look again, and this time we're going to average within the mode of processing level, and we are ignoring the experience, the valence experience independent variable. So we average the 4 and 4 for writing, and we average the 4 and 4 for thinking, and we compare them and say, are these two different from each other? And again, no, they are not different from each other. There is no main effect of mode of processing either. We want to then go on last to our interaction. And we're kind of skipping a simple effect. We don't describe the simple effects yet because we want to know the simple effects are used to answer whether there's interaction. And actually the way this works in real research is we run an analysis to see if there is an interaction, And then if there is an interaction, we go backwards and look for simple effects. So let's just see, is there an interaction right now? For an interaction, we're going to look at the simple effects and see, is there a difference of differences? And if there is, it's an interaction. So the first difference we're looking at, the first simple effect is there an effect of valence on our dependent variable when only looking at writing? So we're going to subtract the top 4 from 4. And then we also have a simple effect of experience valence, negative versus positive, when only looking at thinking activities. So we subtract and we get zeros. Is there a difference between these differences? Is there 0 different from 0? And the answer is no. And we can look at this again, the other version of simple effects, where we look at the mode of processing on well-being, but only with negative experiences, versus the mode of processing independent variable on well-being when only looking at positive experiences. We look at those differences, and is there a differences in the differences? No, there's still not. So here we would say, no, there is no interaction effect. No differences of differences. Cool? So that was the most boring version example I could come up with. Let's go on to something a little bit more interesting. Example data number 2. So here we have something a little bit different. Here, there's clearly lower well-being within the negative experience and higher well-being when doing anything related to the positive experience. So let's start off with our questions. Oh, well, now let's start off with our visualization. I'm always forgetting. There we go. Here we have negative versus positive. Now we're starting off with our question. Is there a main effect of valence? So we are going to average within each level of valence while ignoring the mode of processing. So within negative, we average the 2 and 2. We're going to get 2. And within positive, we average the 4 and 4. And we want to know, is that 2 different from 4? And we'd run a statistical analysis to find, are those marginal means different from each other? And we're not going to run analysis. I'm just going to say you can eyeball it. Yes, 2 is different from 4. So we'd say, yes, they're different. So yes, we have a main effect of valence. We found a main effect of valence such that participants who reflected on a negative experience reported lower well-being than participants who reflected on a positive experience. Yay, we found something interesting. And we could have done this if we had only run an experiment where we were just talking to people about their negative versus positive experiences. If we had never done mode of processing in our experiment, this is exactly what we would have found. The main effect would have been there. But when we're doing a factorial, we also add in the second main effect, and this is for the mode of processing. So here in our visualization, we have the 2 versus 4 in the writing, whether it's a negative versus positive, and within thinking 2 versus 4. We average those, we get 3 and 3, and we ask, are those different? Well, I don't think so. So here, is there a main effect of mode of processing? No. The average marginal means 3 and 3 are the same. Third question, is there an interaction effect? So we look at the simple effects, and are they different? So here is one version of looking at the simple effects. We can see, is there an effect of valence experience on well-being when only looking at writing, that 2 versus 4? And then is there a simple effect of the experience valence, negative versus positive, when only looking at thinking activities? So we subtract them, we get 2, they're both negative 2. Are those different from each other? No, they're not. But of course we want to look at it the other way, or we could look at it the other way, and we see the same thing, where the simple effect of the writing mode of processing within the negative level of experience of valence is no different from the mode of processing effect on well-being when only looking at positive experiences. It's still 0, 0. So are those differences different? No. You see how, regardless of which way we looked at the difference of differences, which simple effects we were comparing to each other, the answer is the same. There is still no interaction effect, and that's always going to be true. The simple effect analysis we can look at in different ways, different combinations, but they're always going to tell us the same story about an interaction effect. So let's go to example number 3. Here we have pretty similar to what we saw before. So let's see if you can kind of play along with me on this one. Let's look at the graph here. You can pause it and take a minute to look at what are you seeing, what kind of story. Then we'll go on to our questions. Is there a main effect of valence? Take a second to think. What do you think? All right, well, let's go to our view, and we're going to average those marginal means. So within valence, we're going to look at just negative. What's the marginal mean of negative experiences versus what's the marginal mean of positive experiences? So we average them together. We get that 3s. Are they different? Nope. All right, so no, there's no main effect of valence. But is there a main effect of mode of processing? Give it a second to think about it. Look at it. Okay, here we're going to look at the main effects. So within the, ignoring the valence, so just the writing, we're going to average all of those people who did a writing activity and then average all of the people who did a thinking activity. And are those different? Yeah, they are. So yes, we found a main effect of mode of processing, such that participants who wrote about their experience reported higher well-being than participants who thought about the experience. Yay for us. Again, we could have done this with a simple one-way analysis, but here we go. And then our final question, is there an interaction effect? So going to the data, we want to compare differences of differences. Here we have one simple effect is 0, the other simple effect is 0. This is one way of looking at it. We could do the same thing and see here, simple effect of 2 versus 2. Again, there's no difference regardless of which way we look at those simple effects. So no, there's no interaction effect. So now we've seen 3 examples, one where there was no main effects at all, and then 2 where there was a main effect of one independent variable, but not the other. And in all 3 of these examples, there's been no interaction effect. So let's go on and see maybe an example where we do find an interaction effect. What does that look like? So here is example data pattern number 4. Well, here we have a lot of difference going on. We have 4 and 2, 6 and 4. We have different levels of well-being depending on the different combinations of mode of processing and experience. Here's a visualization of it. You can take a minute to look at, make sure you're interpreting bar charts correctly. And then we're going to go to our questions about main effects. So let's start with valence, as we've been doing. Oh, here we look at the marginal mean. This time we are averaging the 4 and 2 for the negative experience, and we're averaging the 6 and 4 for the positive experience, ignoring mode of processing. So we get a 3 and a 5, and we want to know, are those different from each other? Yeah, they are. We found a main effect of valence, such that participants who reflect on negative experience reported lower well-being than participants who reflected on a positive experience. Yay for us. Okay, let's do the other one. Comparing across the within mode of processing, ignoring the valence experience. 5 versus 3, is that different? Yes, again, it is. Woo for us. And now, is there an interaction? Okay, I think I lied before, because we're going to look at this and we're going to see, ow, the simple effects are still the same. There is a decrease, a -2 effect of negative versus positive when you're in the writing, the same thing for thinking. And we can look at it a different way and see that there's an increase of mode of processing from writing to thinking within a negative, but the same thing is true in a positive experience. So here we have no interaction effect. So I was excited. I thought we'd get an interaction effect on this next example, but we're actually not getting one. I forgot the order of my examples. But we do see 2 main effects. Again, all of this could have been done with 2 different one-way studies. But now, I'm pretty sure we're going to see an interaction this time. Here we go with example pattern number 5. All right, here we go. So this time we have all 6s and there's a 2. So something's going on in that thinking about a negative experience that looks pretty different from everything else. Here we have that bar chart visualization of this data, and you can clearly see that there's not really anything going on within the writing condition. And it looks kind of similar in at least positive thinking, but there's something that stands out there with the negative thinking. So we're going to ask ourselves, is there a main effect of valence? Here we're looking at the marginal means. We're going to look within negative and then within positive and compare them. So a 4 versus 6, is that 2 Is that 4 different from a 6? Is that 2 difference? And we would say, sure, for the purposes of our easy example, a 2 is significantly different. So yes, there is a main effect of valence. And this is the same write-up. We're saying that participants who reflected on negative experience reported lower well-being than participants who reflected on a positive experience. So then we do our main effective mode of processing, and we get those marginal means, and we see, are they different? And the 6, yes, is different from 4. So again, we have a main effective mode of processing. And then we go on to our interaction effect. Here we're going to look at the 2 simple effects. So we see that when we are looking within the writing level of mode of processing, and we're looking at the effect of the IV valence on the well-being dependent variable, we see no change. The simple effect is 0. But when we switch our simple effect to look at that valence on dependent variable within the thinking level of the mode of processing, here we have a very steep slope, a -4, or a 4 difference there. So something is going on different here. Let's look at the other version of the simple effects. Here we have, when looking at mode of processing independent variable on dependent variable, when only thinking about negative experiences, we see there's a big difference there. But when it's a positive experience for writing or thinking, it doesn't matter. So we have different simple effects, and that means there is a difference of differences. And so we're saying, yes, there is an interaction effect. So this is the first time we're seeing an interaction, a differences of differences. We found an interaction effect such that writing was more beneficial than thinking, but only for negative experiences. That's one way of saying it, but interactions are always, we can look at them in different ways, so we can also say them in different ways. We could say we found an interaction effect such that reflecting on positive experiences was better than reflecting on negative experiences, but only in the thinking condition. You see how there in the interaction effect, I'm describing the effect of one independent variable on the dependent variable, but also declaring the level of the other independent variable, how that might play into it. Okay, so that is an interaction effect. Let's go to example number 6. Here we have some really interesting stuff going on. We're seeing switches between 2s and 4s. So let's visualize it. I'm going to give you a spoiler alert. This is going to have an interaction. Let's see if you can figure out what kind of interaction it is, though. So we're going to go through our main questions. Is there main effective valence? Now here we have the 2 versus 4 in the negative and the 4 versus 2 in the positive, or vice versa. Wait, those are the same. That's interesting. Is there a difference between these marginal means? No. There's no main effect here of valence. Okay, so let's now check out the main effective mode of processing. Is there a difference here? No. Okay, so there's no main effective mode of processing. So far, if we had run two different one-way analyses, 2 different one-way studies. One study that we did was looking at just valence on well-being. We would have found no result, and we would have written home and said, look, valence doesn't matter. Or we could do another study and say, oh, does mode of processing matter to well-being? And we would have written home, nope, doesn't seem to matter. There was no main effect if we had done each of these independent variable analyses separate. But, as I told you, we are going to see an interaction here. Here we see the simple effects when looking at the effect of IV experience of valence on our DV, when only caring about writing at the writing level of mode of processing, we see there's a difference there. But when we're doing that same experience of valence on well-being and looking at just thinking, we see a different kind of simple effect there. There is a difference of differences. And here we have the same thing if we look at it the other way around. There is a difference of the simple effects. So is there interaction? Yes, there is. And for those of you who tried, it is a crossover interaction. So here we found an interaction effect such that writing was more beneficial than thinking about negative experiences, but thinking was more beneficial than writing when doing positive experiences. You see how it switches depending on the level of the other independent variable. And it's very important to convey that when talking about an interaction effect. That's crucial. Again, if we had just done two one-way analyses, we would have found nothing. But because we did a factorial ANOVA with both factors at the same time, it allowed us to do an interaction effect, and we found something interesting here. Another way of writing out this interaction, remember there's always multiple ways, is that we could say we found an interaction effect such that thinking about positive experiences was better than thinking about negative experiences, but writing about negative experiences was better than writing about positive experiences. So that positive or negative within the writing is different than the positive versus negative within the thinking. These are the same finding. If you were writing this up in APA, you wouldn't have to write both of these. You just have to choose one interpretation. It is all the same fact, and it's really just written in whatever way makes the most sense to convey to your reader. So this latest example does a good job of showing why we might want to run a factorial ANOVA, why we might want to include multiple independent variables in our experimental method. And that's because some variables may only have an effect on the dependent variable under certain conditions. You may remember way back to a different lecture, we talked about the idea of moderators and mediators. Well, this is reminiscent of a moderator. A moderator is any variable that affects when or for whom an independent variable is related to the dependent variable. When you are running a factorial ANOVA, if you find an interaction effect, that is a moderation that's happening because the effect of one IV on the DV depends on the other IV. That is a when or for whom thing that's going on. So this interaction is a moderation. And so by including the second independent variable, or more if you're doing more than just two independent variables, you can examine whether one of those variables is a moderator of the relationship between the other independent variable or variables on the DV, and of course vice versa there. When you include it in the analysis, you get more information and you can find out more interesting stuff beyond just, is there an effect here? Because there might not always be an effect unless you are accounting for this other variable. So as a final review, here are again the terminology for the main effects and interaction. The main effect is that overall effect of the IV on the DV, ignoring all levels of the other independent variable. The simple effect is looking at the effect of one IV within one level of the other IV. And the interaction is comparing those simple effects to ask yourself, does the effect of one IV on the DV depend on the level of the other independent variable or factor? We're testing that difference of differences between the simple effects. So that's it for today. Just a reminder that next week, exam 3 is happening. I know we're already there. This is going to cover the lectures about experimental methods, the threats to validity, and then today's lecture of multiple independent variables. It's also going to incorporate information from that review of null hypothesis testing that we talked about in lab that talks about those different types of errors and alpha and how all of that matters together. So make sure to review all of that information along with the lecture slides. We also want to say that there's going to be a lab assignment this week that's due. And this is where you're going to read an article and answer questions, demonstrating your comprehension of that article. I think it's an interesting one. Hopefully you do too. And in the process, you're going to get to do a fun little experimental activity. So make sure you give yourself plenty of time to read and understand the article and do the activity before submitting. All right, that's it for this week. Have a great one. See you next time.